the gravity or the gravitational acceleration will decrease. And when we go above the surface as well, so in that case as well, the gravitational acceleration also increases. So at the surface, the gravitational acceleration is maximum, and then it decreases at different heights. And then we talked about what? Then we talked about the potential energy, right? And we calculated the potential energy of two masses, right? So if we have separation and then there is some potential energy, so then we talked about that. And yeah, so gravitational acceleration part we have done. So now let us move on, right? So in the last part, we did this question. So in the last class, we did this question, right? So we were talking about this gravitational potential energy, and we know that the change in potential energy will give you what? That will give you work done. And then we also talked about the gravitational potential, right? So these three things we talked about. So let me just quickly write these things again, and then we'll do some questions. So what were the three things that we studied? That potential, this is simply Gm1 M2 by R minus, this minus represents that it is bounded, and then we have work done. So work done was what? Work done in moving an object from one place to another place. So that is final minus initial potential energy. That is delta U. And then the third thing that we talked about was gravitational potential, and this was simply minus Gm by R. So that was the gravitational potential. So remembering these things, now let us do the rest of the questions. What was the other question? Yeah, this one. So this is the question. In this question, what is they are asking? The work done to raise a mass m from the surface of the earth to a height h, which is equal to the radius of the earth, is equal, right? So what is the work done? What is the work done in moving an object from some height to another height, right? So the work done to raise from the surface of the earth to a height h, which is equal to the radius of the earth, right? So what is given? This height h, right? What is the relation between this height given? What do we know about this height h? Yes. So this height h, what is the information about this height h? Remember, we have to calculate the work done. So that we know that this would be delta U, which is the U final minus U initial. That we already, right? So we have an object, right? This is our Earth, and this is the radius of the Earth. So some object was here. Initially, some object was here. So it had some potential energy, right? Now we lift this object. We lift this object to certain height. So now the object is here, right? And this height is h. So this would be some final potential energy, right? So there is a change in potential energy, right? And Then we have to calculate the work done, so that would be just change in potential. So we already know that U initial, that would be how much? So that would be the center is right. So this mass is ME, or let's write it capital M. This mass is small m. So what would be the potential energy? What would be the initial potential energy? Tika, what would be that? Yes, what would be the initial potential energy, Satika? Initially, what do we have? We have some mass m, that is mass of the Earth, and then we have this object, and their separation is the radius of the Earth. And so this is the initial condition. So this is the small mass, and this is the Earth's mass, right? And the separation between them is R. So simply potential energy would be GMM divided by R, right? This is the case first. And then what is the case second? So in second condition, now the separation between them, what is the separation between them? So separation between them from here to here, that is R, from here to here, that is H. So the separation between them is R plus H. This mass is M, this is small mass is M. So then in case second, what is the final potential energy? That is GM M divided by R plus H. This is the final potential energy. Now we have to calculate the work done. So work done, what would be work done? So this is simply change in potential energy, final minus initial. So how much is that? Final is minus Gm m by R plus H, and then this is minus of minus Gm m by R. So this minus minus will be cancelled and it will become positive. So this is minus GMM by R plus H, and this is plus GMM by R. So let us write it in correct order. So this is GMM by R, positive one first, negative one later. So this is the thing. Now proceed further, right? There is important thing which is given. There is a very important information. So this height h, right? What is the condition on this height h? What is that? What does this statement telling us? Height h, right? What does this statement telling us? Yes, Siddhika, please tell me. What is this? What is the meaning of this statement? Yes, Siddhika, what is the meaning of this statement? So height h is equal to the radius of the Earth. So this is given. This is very important information, right? So in here you are given h equal. This is very important. So now you put this thing in here, right? Put this thing in your solutions. This would be how much? R plus R. So this how much? Write it here. GM by R minus G by R. So we can take the LCM, that is 2R. So this 2R and R is cancelled, you have 2. So 2 will come here. Minus 2R, 2R divided, so you have 1. So 2 GMM, 1 GMM, then you have only 1 GMM. 1 GMM divided by 2R. So this is your what? GMM by yes, I got disconnected. Yes, I think I got disconnected. Sorry about that. Share my screen again. So as I was saying, what I was saying that yeah. So we know that this is the thing, right? So this is not in the options. In the option, they have written in the form of the small g. So we have to write it in terms of small g. So how can we do that? So this m and this m cancels, and this small g is gm by r square. So we can write this as gm by, this is capital N. So gm by r, right? So gm by r is gr. Gr is gm by r, right? So we can put this value of gm by r, and this would be how much? So this would be m and then gr divided by 2. So this would be the work. Gm by r, you have put gr, and then mass is there. So this is the option. Okay, so this is the option. Is it clear to you, Siddhika? Is it clear? Is it clear to you, Siddhika? Oh, good. Then please note it down. Please note it down, and then we will do another question. Yeah, whenever you want me to scroll down the screen, please tell me. Whenever you have noted, please tell. Yeah, whenever you want me to scroll down this screen, please tell. Then please come down this one. From here, right, yeah, whenever you have noted it down, please tell. Yeah, good. So this was yeah, this was whenever you are right putting or lifting some object from one place to another place, then you are doing some work. So that what is the work. So this was that question, and then the next question is right. Okay, so in this question, at what height from the surface of the Earth, the gravitational potential and the value of G are this respectively. Take the radius of the Earth as 6,400 kilometers, right? So the gravitational potential is given, and the value of G, that is also given, right? So in this question, what they are asking, first let us write what are the given things, right? So first it is given that gravitational potential, and this is joule per kg square, so that is in SI units, right? So that is there. And 5.4 into 10 to the power 7 joule per kg square. So this is potential at certain height, right? In the question we have to, and the gravity at that height, that is also given. What is that? This is minus 5.4. So this is 6 meter per second square. Right. Both these values are given, and you also know what is this radius. So 6,400 kilometer, but we have to write it in meters. Right. So this is 6,400 and then 10 to the power 3 meters. These are the given things. And we also know what do we need to calculate? We need to calculate the height at which that certain object is. So we have to calculate the height, right? So how can we calculate that? So what do we know? We know that, right, what do we know? We know that we have this earth, right? Again, whenever we make that diagram, so the answer becomes very easy. So we have this earth, right? It has some radius which is 6,400 kilometer, right? And then what else do we know? We know that the object is at certain height. So the object is at certain height. So let's say this is h, and this thing we already know, that is the r, right? So the potential gravitational potential due to this earth, and that is experienced at this point. What would be the gravitational potential? So that V would be minus G and M divided by R plus H. Right. So this is the value. G is minus GM by R plus H. And what else do we? What else do we know? We know that GH. What is GH? So this thing, right? This is generally G 1 minus 2H by R. But this happens when this R is very much greater than this H value. So we don't know about that. So let's write a proper formula for that, right? Because, yeah, so how do we do that? We know that F force between these two things would be how much? That would be G M M divided by R plus H whole square, right? So we know that this is equal to how much? mgh. And this is gmm by R plus H whole square. So this m and this m will cancel. So we have the value of gh. This is simply gm by R plus H whole square, right? So what do we have in here? So we know that this GH is how much? So this GH or this V is how much? So we can put the value of GM, right? We can put the value of GM from here or here, right? And let us write this potential in a positive way. So let's take that this is positive. So this is GM by r plus h, right? And remember, we have to calculate this h. So gm, right? This thing, we know the value of this g, but we don't know the mass of the earth. So we will put the mass of the earth from here, or whatever value we can take, because we know this thing, we know this thing, and we know r. So using that thing we can calculate. So let's calculate gm from here. So gm is how much? Gm is v r plus the h from here. And we put this value in here. So gh would be how much? gh is v r plus h and divided by r plus h whole square. So 1 r plus h will cancel. And what would be in here, right? So what would be in here? R plus h. R plus h would be how much? R plus h into gh. That would be simply v. Right. This is how much? So we know that this R plus H, so R is 6400 GH, or we can put the value of GH as well, right? So R plus H, and this is V by GH. So how much is V? V is minus 5.4 into 10 to the power 7, right? This is minus 5.4 into 10 to the power 7. And GH is how much? So GH is 6 meter per second square. So this is 6 meter per second square. So this is how much? This is 0.9. So this is how much? This is minus 9 into 10 to the power 6. This is R plus H. And then your H will go the other side, right? Or H we can calculate using minus 9 into 10 to the power 6, right? And then this is minus R. R is how much? So this is 6.4 into 10 to the power 6, right? Oh, so this minus we have to keep, right? Minus, this is minus, this is minus, right? So this minus we have to keep, so this will become minus minus, this is positive. This is positive, and then minus of 6400 into 10 to the power 3. So this is how much? This is 9 into 10 to the power 6 minus 6.4 into 10 to the power 6. Right, because this is the 3 powers, 1, 2, 3. So 10 to the power 3, 10 to the power 3, 10 to the power 6. This is how much? This is 6 point, and this is 8. 8 minus 6. So 2 into 10 to the power 6. Right, so how much is this thing? This is 2, 6, and 0, 0 into 10 to the power 3 meters. So this is 2600 kilometers. So this would be the height. Okay. Yeah, and so this important thing was that we have to keep this negative sign, right? Otherwise, we'll get a negative value of h. So height cannot be negative, right? So that is why we have to keep this negative sign. Okay, is this clear to you? Is it clear? Good. So please note it down. Please note it down. So two things were given, right? Potential was given, and the gravitational acceleration at a certain height. That was given. So using these two things, we calculated this height. First, we write what is potential, then we write what is GH, and then we put the value of this potential in here, and then yes, this will be minus. Whenever you want me to scroll down the screen, please tell me. And this is a very important very, very question. Then, okay, then please note down this question. That is charge. Yeah, okay, so now let us do the next question. So this is the same question, and this is based on again potential. So infinite number of bodies, each of mass 2 kg, are situated on x-axis at a distance 1 meter, 2 meter, 4 meter, and 8 meter, respectively from the origin. The resulting, so infinite number of, right, the resulting gravitational potential due to this system at the origin, right. So we have to find out, right, we have to find out that what is the gravitational potential at the origin. But what is given? What do we have in here? Right. So we have, this is let's say origin, right, and at a distance 1 meter. So you have one mass m of 2 kg. This is 1 meter, and then at distance 2 meters. Again, okay, so let me just write 1 and 2 because both are agreeing, right? Right. So 1 meter, this is 2 kg. 2 meter, this is 2 kg. And then 4 meter, this is 2 kg. And then, right. And then we have 8 meters and 2 kg. Then other would be 16 meters and 2 kg. So and so on up to infinity, right? So then we have to calculate the potential at origin. So we have to calculate the potential at origin. So we have infinite number of charges, right? We have this, or not charge, but masses. So this mass m1, this mass m2, this mass m3, and this mass m4, and so on. So infinite masses, and then due to each masses, there would be contribution of potential. So your overall potential, that would be how much? That would be V1 plus V2 plus V3 plus V4 plus so on up to V infinity, right? So this is the overall potential, and because this potential is what? Scalar or vector quantity. What quantity is this, Satika? Scalar or vector quantity? What quantity is this? Yes. What kind of quantity is this one? Potential, gravitational potential. What kind of quantity is this? Scalar or vector? This is the question. So gravitational potential, is it scalar or vector? What kind of quantity it is? Yes, Siddhika, what is say, potential, gravitational potential? So it doesn't require any direction, right? So this is a scalar one. So the solution will be algebraic sum, right? Algebraic sum of individual potentials, because this potential is a scalar quantity, right? Force is a vector quantity, and yeah, other things, velocity and all those things, displacement, those are vector quantities. Torque and all these things, they are vector quantity. But work done, potential energy, potential, kinetic energy, these are scalar quantity, right? So in the case of this potential, we have to just calculate individual ones. So at origin, which is separated by 1 meter at this position, M1, right? So what would be V1? That would be simply how much? Minus of G M1 by this R1, right? Which is 1 meter. right? And this is also we can write it as, because mass M1 is how much? Yes, this is 2 kg. This is 2. So this is minus 2g. And then we have V2. So that would be minus Gm2 by R2, which is how much? Minus Gm2 is again 2. R2 is 2 meters. Right. So this is minus 2g by 2. Right. And then what do we have in here? So V3. V3 is how much? Minus Gm3 by R3. So this is minus G and again 2 divided by 4. So this is minus 2G by 4. Right. So what kind of progression is this? Let's say this is A1, this is A2, this is A3. So what kind of progression is this? Yes. And this is going to infinity, right? So what kind of progression is this? You will get your potential something like that. So minus 2g, minus 2g by 2, minus 2g by 4, minus 2g by let's say 8, and so on. Right. So this is the thing that you are getting, and let's say I take out minus 2g form. This is 1 plus 1 by 2 plus 1 by 4 plus 1 by 8, and so on, right, up to infinity. So this is what we call geometric progression, GP, right, in which you have a common ratio. In AP, in AP we have a common difference, right, which is D. In GP, we have common ratio, which is R, right? And how do we calculate this R? So R is A2 by A1, right? So A2 is how much? A2 is 1 by 2 and divided by 1. So this is 1 by 2. Similarly, if we calculate from here, right? So A3 by A2, that is how much? That is again 1 by 4 divided by 1 by 2. So again 1 by 2. So common ratio is same, and R is less than 1, right? R is less than 1, and common ratio is same. So in that case, and this is going to infinity. So in that case, the sum of GP is given by A divided by 1 minus R. So this is your sum to infinity terms. This is how you calculate the GP, right? So this is sum to infinity terms. This is A1, A2, A3, A4, and you are calculating the sum of all those values. So sum is simply A by 1 minus R, right? So this would be how much? A is 1, right? And 1 minus R is how much? That is again 1 by 2. So this would be how much? This is 1 by, this is 1 minus half is half, and then this 2 goes upstairs and it becomes 2. So S infinity is, this is 2. And then you put this value in here, so what you will get? You will get minus 2g into, so this part will give you, and then this is minus of 4g. This would be the total potential. Is it clear to you? Is it clear? Yes, is it clear to you, Siddhika? Okay, good. So have you studied GP, geometric progression? Have you studied that? Oh, you have not studied GP. So yeah, GP is the same thing like arithmetic progression. So in arithmetic progression, what is the series? You have A plus D, A plus 2D, right? A plus 3D. So this is your AB, right? Right. Is it clear? And you calculate SN, AN, and all those things in AP. Similarly, you have GP. So how this is defined? GP is A and then AR and then AR square and so on. Right. So this is GB and then you calculate SN, AN of GB. Right. This is called geometric progression. So let's say you have 1, 2, and then 2s are 4, 2s are 8, 2s are 16, 2s are 32, and 64, this kind of progression. So you see that first term is 1, second term is multiple of that, and then if you multiply 2, so that is 4, and then we multiply 2, so that is 8. So same thing is multiplied. In AP case, same thing is added. And in GP, same thing is multiplied. So that is the only difference between AP and GP. And you have S infinity. This is equal to A by 1 minus R. This is a very important relation, right? So this is a very important relation, and this thing you have to remember. So this A is first term, and this R is common ratio. So this is about GP. So in here we had to calculate sum to infinity terms, right? And this was a GP. How did we prove that? We calculated common ratio, and then we saw that common ratio is same. In case of AP, if common difference is same, then that is called AP. In case of GP, when common ratio is same, then that is called GP. So that was the idea of this question. Please note it down, and if you have any doubt, please tell me. Note it down, Sandeep, what happened. So please note it down. Yeah, whenever you want me to scroll down the screen, please tell me. Yeah, whenever you have noted, please tell me. Yeah, whenever you want me to scroll down the screen, this is the correct. Whenever you want me to scroll down the screen, that page. Okay, noted up to this point. Yes, noted. Yeah, please note down the points. Yes, whenever you have noted it down, please tell. Okay, good. So then let us move on to the next question, right? And so, yeah, good. Okay, so we'll do one more question and then we'll move on to the escape and Lect. Escape and orbital velocity. Yeah. But first, let us do this last question. Okay, a body of mass m taken from the Earth's surface to the height equal to twice the radius of the Earth. The change in potential energy of body will be. So this is exactly the same question that we have done in here. Right, exactly the same question with that question. So exactly this one. Right, exactly this one. And yeah, we have to, in case of this question, we need to calculate work done, but that is ultimately change in potential. Right. So in this question also we have to calculate the same thing. So we'll quickly do this problem, right? Let us quickly write this thing. So yeah, what is given in this case? One, that we are moving this object from this R Earth surface to height equal to certain height, right? And this height is equal to twice the radius of the arc. So this is a given, right? So initial potential energy is how much? Minus G M M by R. And the final potential energy is how much? Minus G M M by R plus H. And H value is given, right? So this is G M M by R plus R. So this is minus G M by 3R. So these are the initial and final potential energy. Difference is delta. This is minus G M by 3R minus of minus G M M by R. Oh, again, this is in terms of mg. So yeah, that. So this is G M M by 3R plus G M M by. So again, we write the positive things first. So this is G M by R minus G M M by 3R. So LCM is 3R. This is 3GM M minus GM. So this is 2GM M by 3R. And we already know that GM by R. We have already calculated that this value is GR. Right, so we'll put this value. So this is 2mgr divided by 3. Your change in potential energy is 2 by 3 mgr. This would be the answer. That getting the option is yeah. So is it clear to you, Satika? Is this question clear? So yeah, good. Yeah. So then please note it down. Right. What did we do? So we took this object from surface and then we lift this up to this height. Then change in potential energy out. That was the question. Please note it down. And whenever you want me to scroll down the screen, please tell me. And then, yeah, then you want to orbital and escape velocity. So orbital velocity of our satellite. and then escape velocity from the surface or from the enemy point, right? Yeah, whenever you want me to scroll down this thing, that. Yeah, whenever you want me to scroll down the screen, please tell me. Done. Good. So then please put down. Whenever you have noted it down, please. Okay, good. So this completes the potential energy, work done, and all those things. So now let us talk about orbital and escape velocity, right? So what is orbital velocity? What is escape velocity? So, yeah. So first, let us talk about the orbital velocity. Orbital velocity, and specifically, we will talk about orbital velocity of satellite. Right. So then, first thing is this word which is orbital. Right. So this is made up of word orbit. Right. So an object which is moving in an orbit. Right. So let's say the orbit is circular. For simplicity, let's take the orbit to be circle. So we have this Earth, right? This Earth has some radius, and then you have another satellite, right? Which is oh, what is this? Why this is absent? I have picked. Oh, yeah. So this is a satellite, right? This is a satellite which is right. This satellite is rotating like this, and because this is moving in circular orbit, right? So at the center, some force would be acting. And what is that force? Can you tell me what is that force towards the center? What is that force? Yeah. What is that force which acts towards the center? What is that force? Right. What is the force which acts towards the center? This is your Earth. This is the satellite. Right. Let's say this is at some height h. This is at height h. Centripetal force. Yes, absolutely right. Good. So the force acting towards the center, that is the centripetal force. Right. So from here to here, the height is h. Right. So same height is there, and the centripetal force is acting. And what is providing that centripetal force? What is the thing which is attracting the satellite towards its center? So what is providing that centripetal force? Yeah. In this case, the centripetal force, what is providing that centripetal force? So in this case, what thing which is, so this Earth is pulling the satellites towards its center. And what is the force that the Earth is applying? The Earth is applying gravitational force of attraction. So in this case, centripetal force is provided by gravitational force of attraction. Right. So in this case, F centripetal is F gravitation. Right, and we are at certain height. So then what would be this? The centripetal force, we know that that is how much? That is mv square by r. This is the centripetal force. So if we write this thing, so let us write this as v orbital. V. This is m O square by r. And what is the gravitational force? Gravitational force is gmm divided by. Oh, so this is not the height, so this is r plus h. And this is r plus h whole square because this is at certain height. Right, so this total distance is r plus h. Okay, so this r plus h, this thing will cancel, and this m and this m will cancel, and what we will get? So v orbital square, that would be gm divided by r plus h. And if we calculate v orbital, so that would be gm by r plus h. Right. So this thing is here. Or this is called the orbital velocity. And if the satellite is at the surface of the Earth, so at surface, what will happen? Your h is 0, so v orbital is simply gm by r. Right. So please quickly note it down. Right, and in the next class we'll do couple of questions on the basis of. Please note it down. And in the next class we'll do couple of questions and then we'll start the second. Yeah, please quickly note it down. Yes, sir. Please note it down. Then good. Okay, so yeah, we'll stop here and see you in the next class, Siddhika. All the best for your preparation. All the best, and yeah, see you in the next class, Siddhika. Bye.